Since we have started with our dynamic arrays, right? So we have seen the syntax of dynamic array, how your dynamic array is going to look like, and how to create the memory, how to allocate the memory for your dynamic array, what is the syntax for your dynamic array, this and all things we have seen, and what are the methods which we are going to follow for storing the elements into the dynamic array and for getting the elements out of this dynamic array, this and all we have seen, right? Now, in this particular session, let us continue with the discussion of dynamic arrays. Let us see the 2D dynamic arrays. Let's say if I want to create a 2D dynamic array, how I'm going to create? Again, the same thing. I'm going to first mention the data type, followed by the array name and the first dimension and the second dimension. Here, the first dimension, as we already know, we are going to have the number of rows, and the second dimension will tell you the number of columns. Okay. So this is how you're going to just create a 2D dynamic array. 1 minute, I'm getting a call. 1 minute. So basically, the first dimension is basically saying you the number of rows, and the second dimension is saying you the number of columns. Okay. Now, if we want to create the memory for this 2D dynamic array, how I'm going to create is, so within an initial beginning block, during the runtime only, I'm going to create the memory for this dynamic array. So within an initial beginning block, I'm going to write down dyn is equal to new of, let's say, 5. Okay. So if I'm going to write down dyn is equal to new of 5, then I'm mentioning the dimension or the number of rows. I'm basically creating the memory for rows. Okay. I'm mentioning there will be 5 number of rows. Okay. Now, after creating your memory for your rows, if you want to create the column, then how to create is, for every row, we are going to create the column memory. Okay, how to create it? So you can use for each loop for that. So using for each loop, for each of dyn of I. So for every row, for I is equal to 0, that is for first row, you are going to create the column memory. So you're going to write down dyn of I is equal to new of, let's say, for every row we need 3 columns. You're going to write like this. Okay. So a dynamic array will be created with 5 number of rows and 3 number of columns. So 1, 2, 3, 4, and 5 number of rows and 3 number of columns like this. Okay. So this is how you are going to create a memory for a 2D dynamic array. And let's say if you want to store a data over here, how you're going to write down dyn. So this is first, second, third row. Dyn of 2, and this is first column, second column, which is equal to. So the element 2 will be stored over this particular location. Okay. So this is how you're going to create a two-dimensional dynamic array. Is it clear for everyone? So first you need to create the memory for your rows. You need to create your rows, and next for each row you need to create a column. Okay. Is it clear? Great. Okay. Now let us see another scenario where if we have a dynamic array where the number of rows are dynamic in nature, the number of rows are dynamic, and the columns are fixed. This is the condition we have. Okay. So we have a situation where your number of rows are dynamic and columns are fixed. For example, we can simply have int dyn. The number of rows is dynamic and the columns is fixed. Okay. So how to create this array? So simply we are going to write down dyn is equal to new of, let's say, 3. Within an initial beginning block, I'm going to write this down. So what is going to happen is the number of rows will be created. 3 number of rows will be created, and the columns are already fixed. That is 5 number of columns. Okay. Just we need to create the memory for our rows. That's it. Okay. And let me show you something in this playground. Let me create a array module example, and let me create a dynamic array with rows as dynamic and columns as 3. Okay. Now within an initial beginning block, if I'm going to write down dyn is equal to new of, let's say, 3. So the number of rows will be 3 and the columns will also be equal to 3. Okay. Now let us see the size of this dynamic array. Dollar display. The size of dynamic array is percentage d comma dyn dot size. Let me run it and let us check it out. Okay, sorry. I haven't shared it. 1 minute. I think now it is visible, right? Yeah. So what is that we are going to get? The size is nothing but 3. So we have 3 number of rows, right? So basically it is going to show you the number of rows, that is nothing but 3. Okay. Let's say suppose if I want to store the data in the first row, first column, dyn of 0 and 0, which is equal to 1. Okay. And let me display it also. Dollar display percentage p. Let me show in packed format, comma dy. So this is my dynamic array where the first row, first column is equal to 1 and remaining all are equal to 0. Okay. And if you carefully observe, if I'm going to use a size operator, then size function, then it is basically returning by the number of rows. Okay. Yeah. So this is how I'm going to create a dynamic array. Now let's say suppose if I'm going to write down dyn of 0 is equal to 3. What I am referring to, can anyone tell me? If I'm going to write down dyn of 0 is equal to nu of 3. What am I referring to? Can anyone tell me? Exactly. So I'm basically referring to first row. I need 3 number of columns. Let me run this and let us see what are we going to get. If I'm basically referring to dyn of 0, nu of 3, let us see what are we getting. So see, illegal use of dynamic array new operator. So because I have basically created the number of columns are fixed, right? So you cannot dynamically create it. Okay. Let's say if I remove this and let us check it out. What are we going to get? Now there is no error. Okay. If you have fixed the number of columns, then you cannot create it dynamically during the runtime. But if you haven't declared any column number, then you can create it. But if you have already declared, you cannot create it. Is it clear? The difference is it clear? Yeah. Okay. So that is case one we have. Now the case two, let us see. So here rows are dynamic and columns are fixed, right? So let us see the second case where your rows are fixed. You have fixed number of rows and the columns are dynamic. You can create different columns. Okay. For example, if I'm going to have int dyn 3 and I've left empty. The column space I've left empty. Okay. So how it is going to look like? So 3 rows you are going to have, and in each row, how many columns you are going to have, that you haven't decided yet. Okay. So within an initial block, you can have it. Okay. So what you can do within an initial begin block, initial begin, you are going to write dyn of 0 is equal to new of 3. That means in the first row, this is my first row. In the first row, 3 columns will be created. Let's say if I'm going to write down dyn of 1 is equal to 4. Then in the second row, 4 columns will be created. I mean new of 4. And let's say if I'm going to write down dyn of 2 is equal to new of 1. Then only one column is being created. Okay. So this is how you can create a dynamic array, 2D dynamic array. Is it clear for everyone? Any doubts or any queries in this? Great. Okay. So that was about your dynamic arrays, and also you can explore 3D dynamic arrays. So the way I've explained it. So once please explore 3D dynamic arrays, how they are going to work. Please try to have it. All these methods which I've discussed it. It's just a small task for you. Please go through it. Now, so what are the drawbacks which you have observed in your dynamic arrays? Can anyone tell me? What do you think the drawback of your dynamic array? Have we any? Do we have any drawback in the dynamic array? Exactly. So the memory allocation, the name is dynamic array, but the memory allocation is mandatory in the during the runtime. You need to mandatorily have the memory size declared using the new operator. Am I right? Yes. And that is the main reason we are going to another type of dynamic arrays. So that is nothing but my queues. Okay. So I am going to have something known as queue. So this queue is a basically it's a type of memory where you don't need to declare any memory. No need to declare any memory during the runtime or during the compile time also. Let me write down here. No need to declare memory during runtime and also during compile time. Okay. Now basically coming to the syntax, we have the data type and the variable name, and we are going to declare it with dollar symbol. Okay, if we have empty brackets, then it is a dynamic array, and if we have declared it with dollar symbol, then it is a queue. Okay, for example, if I'm going to have int queue with a dollar symbol, then it's just a simple queue. And what is the size of the queue? How many locations are created? No locations are created. Okay. Then when are the memory location or when is memory is allocated for this queue? Whenever you have entered any element, then automatically a memory allocation will be happened for this particular queue. For example, if we have declared a simple queue int queue with this symbol. Now, initially no memory has been allocated. Okay, if you use the dot size function also, you are going to get 0. Now, let's say if you are going to enter any element into this queue, how to enter any element into the queue? Again, we have array aggregate method which we can use for entering the elements into the queue, or else we can use some built-in functions like insert for entering the elements into the queue, or else we can use another function which is push underscore front and push underscore back. So this we can use the built-in functions which we can use. So whenever you are going to enter any element into this queue, automatically the memory will be allocated for this queue. Okay. So let's say, suppose initially there is no queue which is present, and if you are using any of this method, and if you are inserting any element into the queue, then the first element have been entered and a memory will be created. Let's say we have entered the number 5. Next, let's say we have entered another element using this push underscore friend. Then a particular data will be entered like this, and the data will be 10, and the queue size will be 2. It is automatically increased. And let's say if we have inserted another element in the front, then the queue size will be automatically increased to three locations. Let's say if we have removed this particular data, then the queue will be automatically updated to two number of locations. So you don't need to use new operator for declare for increasing the memory or for decreasing the memory. Okay. So queue will be dynamically increasing its size or shrinking its size according to you when you are inserting the elements or removing the elements. Okay. So let us see an example for this. Let's say if we are going to declare a simple queue, and if I'm going to declare a queue with the symbol and within an initial beginning block, first let us see the size of the queue. The size of dot size. So the queue size is equal to basically 0 because no element is inserted, and by default the size is equal to 0, right? Now let's say if I'm going to have, uh, let's say I'm going to use q is equal to array aggregate method I'm going to use, and I'm going to insert two elements. Okay. And let me display the size again. Let me display the size as well as the contents of the queue. For displaying the contents of the queue also, you can again use for loop, for each loop, and array percentage p operator. Okay. So let me use it. The Let me display the values of the queue. The value of queue is percentage p. So the size of the queue is equal to 2, and the value of this queue is equal to 1 comma 2. Okay. Now let's say if I want to insert any element into the front of the queue, I have a queue with me. So like this, if I have a queue with me where I have two elements, 1 and 2, which are already present, and if I want to insert another element over here, so I can use a method which is known as push underscore front. In queue, we don't declare size manually. So in dynamic arrays, you are basically using new operator for declaring the size. But in the queue, if you carefully observe, I'm not at all declaring any memory. So if I'm just inserting the elements, automatically the memory allocation is happening in the queue and it is increasing. If I insert any other element, the memory is increasing itself. And if I remove any element, the memory will be decreasing itself. But in the dynamic array, you need to manually create the memory. Okay. So basically, if you are developing system verilog test bench, and if you are getting some 10 number of transactions, or let's say if there is a possibility that your transactions may increase, and if you want to store that particular transactions into a particular array, okay. So there you can use this queue for dynamically increasing the size. No, dynamic arrays cannot automatically resize like a queue. No, it is not possible. In queues, for each is not working, it may be right or wrong. No, for each will work. You can check it out. Okay, let me use for each loop for displaying the contents of my queue. For each of queue of I dollar display, the value of queue is percentage. Let me display it in binary decimal. So the value of queue is basically percentage d comma q. Or let me declare just the q value. That's enough. What is the spelling? Q U E. Okay. So sorry, percentage d, which is equal to percentage d. Okay. I comma percentage d. Okay. So q of 0 is 1 and q of 1 is equal to 2. Is it clear? Who has asked this? In Q, it works like a FIFO order. It's not, it's a FIFO and a LIFO. You can also have it like a first in, first out, or last in, first out. I will show you. Okay. Yeah. How does copying behavior different between queues and dynamic arrays? Which copying behavior you're asking about? Same question in queue. For loop, it is not working. It may be right or wrong. Is it clear? Who has asked this question? Pawan, is it clear? And how row and column will be declared in queue? Is it possible? There is nothing like row and column. Here you are going to have it in one dimension. Okay. So we will see like in the two dimension what we are going to have. Okay. We are discussing about one dimension queue, right? Yes. Okay. So any other queries? Okay. So this is how you're going to declare a queue. And let's say suppose if you want to insert any element in the front of your queue, how you're going to use do that. So you're just going to write down queue dot push underscore front. And let's say if I want to insert an element 3. So push underscore front is a function which I'm going to use for inserting the elements inside into the front of my queue. Okay. And let's say if I want to push the element from the back of my queue, I'm going to use queue dot push underscore back of 5. Okay. Now let's say I can also use one more method which is known as insert. Queue dot insert. I need to first of all mention the index. Okay. So let's say the index is 1 and I'm going to have the element as let's say 2. Okay, let us see. Let's say 10. Okay, so at index 1 the element 10 has been inserted. So you can also randomly place the elements inside my queue by using this insert method. Okay, yeah. Yes, yes. I don't know which behavior, but it what behavior you're talking about? I didn't get your question. How does copying behavior differ from queues and dynamic arrays? Okay, I need an elaborated question. What exactly you're talking about? What copying behavior? Okay. Can override in queue. What do you want to override? Okay. So this is nothing but inserting. Yeah. And if you're inserting, if you carefully observe, previously the values were 3125, right? So previously, let's say the values are 3125. 3125. And if you're trying to insert any element into this queue, nothing is being overridden. So the queue size has been increased and the element has been inserted and the other elements are shifted towards right. Okay. So this is how your queue is going to increment dynamically. If you are trying to insert any element, then no overriding is not going to happen. Yeah, I think now your doubt is being clear, right, ChatGPT? Yes. And let's say if I want to remove the elements from this queue, I'm going to use a method which is known as queue dot pop underscore front for removing the elements from my front of my queue. Okay. So no argument is required for this. Okay. So I can simply have it like that. And I can also use uh, pop underscore back so that I can remove the elements from the back of my queue. Okay. Yes. And if I want to delete entire queue, I can use delete method for deleting my entire queue. Yes. So this is how you are going to work with your queues. Okay. Yes. So any doubts or any queries in this particular queues? Please let me know in the chat box. So using this pop method, you can basically get the data out of this queue. Okay. So let me declare one variable int m. Okay. M is equal to q dot pop underscore front, and let me display this m value. Dollar display, the value of m is percentage the comma m. The element will be removed from the queue, and if you want you can store it inside m. Where is the m value? That, yeah, m is equal to 3, you can see, right? So the first element was 3, that was given out of the queue. Can you show me the insertion of element at rear, end, or front? Okay. So before that, the popping, is it clear for Pranav and Bhavana? Yeah. So let me insert the element at the first position. See, 10, 3, 1 to 5. Okay, Logesh.